So today we're going to be in the column with numbers 99 through 107. So without further ado, let's go ahead and jump in to question 99. Okay. So we look at a numbered cube labeled 1 through 6 and it's rolled. We want to find the probability that the cube lands on a number less than 5. So our probability, this is just basic probability, out of 6 possibilities, a number less than 5. So out of those numbers, I have numbers 1, 2, 3, and 4. So I have a 4 out of 6 chance, or if I reduce that, a 2/3 chance. And if I work that out as a decimal, 2 divided by 3 is going to give us a 0.6 repeating, or 66 point, do we have a decimal? No. 66 point, we're going to round that to the first decimal, 7%. So we have 66.7%. Basic probability. Question 100, another basic probability question. We have the same dice, numbered 1 through 6, and what are the chances it rolls an odd number? So the probability is out of the total. We have 6 possible rolls. Odd numbers are 1, 3, and 5. I have 3 of those. 3 out of 6 is going to reduce down to 1/2, which is 0.5, or 50%. That's question 100. Question 101. We're looking for, again, a probability. Out of a dice labeled 1 through 6, I have a total of 6 possibilities. If I want to roll a 3, there's only 1 out of those 6, which that does not reduce. So I'm trying to find a 1 divided by 6, which gives me 0.16 repeating, or 16.6 repeating, which is 16.7%. If we round to the same decimal we did earlier. 16.7%. Awesome. Okay. So for the next set of questions, we have questions 102 and 103. We're going to use the information below. Given the set of integers 1 through 18, what is the probability of choosing an odd number or a number less than 12? Okay. So now with this, we could count which odd numbers are also less than 12, or we could look at this as a combination of other probabilities. So 102, we have 2 different ways to do this. And I think the way that this is designed to be done is to use the examples that we have. We're looking at an odd number or a number less than 12. So odd number or less than 12. We're looking at the probability of A or B, which is given the equation probability of A plus the probability of B minus the probability that they are both. That way we don't double count the ones that are in both of these sets. So A plus B minus both. Okay. So for all 3 of these, we're going to evaluate out of 18. So it's out of 18 minus out of 18. So the probability of A, that they are odd numbers, 1 through 18 has 9 odd numbers. Probability of B, numbers less than 12, well, that's 11 out of 18. And then what are the chances of A and B? So A and B are the odd numbers that are less than 12. So odd numbers less than 12, 1, 3, 5, 7, 9, 11. Those are my odd numbers that are less than 12. 1, 2, 3, 4, 5, 6. Awesome. Probability of A, probability of B, minus the overlap. This is 1/2. Actually, you know what? We're going to keep this in this format. So 9 plus 11 is 20, minus 6 is 14/18. 14 over 18 is going to reduce down to 7/9, which is roughly equal to, let's figure out what that is. 7/9 is 0.7 repeating, or 77.8%. Okay. 103. What is the probability of choosing an even number or a number greater than 10? Okay. So I'm going to do the same thing. Probability of A or B is equal to the probability that it's an even number plus the probability that it is a number greater than 10 minus the probability that it is both an even number and a number greater than 10. Awesome. So let's see. With this one, the probability of A, which is an even number of 1 to 18, is 9 out of 18. The probability that the number is greater than 10, that would be 11 through 18, 8 over 18, minus the probability of both even and greater than 10. So I'm going to start with 12, 14, 16, 18. So 4 out of those 18 were double counted there in both of those lists. So 9 plus 8 is 17, minus 4 is 13 out of 18, which is going to be roughly equal to 0.72 repeating, or 72.2%. That's 103. Let's take a quick peek at 104. Okay. So we're going to ask how many ways 15 candidates can be chosen to be president, vice president, and secretary of the National Honor Society. So we have a total of 15 people arranged 3 different ways, or 3 different positions. And so we have to ask ourselves, is the order important? If I have president, vice president, and secretary for these 3 people, A, B, and C, if I move A to vice president and B to president and leave C as secretary, is this a different combination or a different possibility of choices? If the answer is yes, then that means permutation. Okay. So with the permutation, we have everything we need to know. Our formula for permutation is going to be, we have 15 choices, permutation, 3 positions. So on the top, we have the number of people, or the number of candidates, the number of possibilities we have, 15 factorial, divided by 15 minus 3 factorial. Now, we know that we can write this out in longhand. We can actually type this out individually and get a huge number, or we could write it out longhand and eliminate a lot of this. So 15 factorial is 15 times 14 times 13 times 12 all the way down to 1. I'm going to stop until we hit 12. Why? Well, because I noticed that at the bottom on here, 15 minus 3 is going to be 12 factorial. 12 factorial is 12 times 11 times 10 times 9 times 8 times 7 times 6. But pause, isn't that what comes after this point right here? So we know that if I have 12 factorial on top and 12 factorial on bottom, those cancel out. My probability, or my permutations, the number of different ways we can arrange this, is just 15 times 14 times 13. And so let's see what that gives us. So we have 15 times 14 times 13, which gives us, there are 2,730 different ways I can arrange 15 people into 3 different positions. It's a lot of different combinations there. Okay. And so let's move on to question 105. Let's take a look at question 105 and see what's going on. Okay. So we have 20 teachers in the math department, So 20 teachers. And the district has funding for 4 of them to go to a conference. How many ways can 4 teachers be selected to attend this conference? So we have 20 teachers and we have 4 spots. Okay, I think that's all we need to answer this. So with 20 teachers and 4 spots, we're going to ask ourselves the same question we asked in the last one. If I have A, B, C, D go, does it matter if I fill spot 1 with B and 2 with A and leave these 2? Are these the same, or is this a specifically different set of data? And in this case, it doesn't matter. So I know that this is a combination, not a permutation. If the order of the spots mattered, you were first, second, third, fourth, permutation, nope, combination. So I know that the formula for combination is going to be 20 combination 4. So a pool of 20 are filling in 4 choices. This is going to lead us to the generalized 20 factorial divided by 4 factorial, 20 minus 4 factorial, okay? And just like the previous one, I know some of these are going to cancel out. So if I look at this and say, well, I have 20 factorial divided by 4 and 16, I'm going to take the larger of the 2, 16, and I'm going to write out my top factorial until I hit that number. So it's going to be 20, 19, 18, 17, 16 factorial divided by 4 factorial, 16 factorial. And I wrote it all the way out to that number so that I could eliminate all of those possibilities that go after that, because those will eventually cancel out. And so in essence, this is 20 times 19 times 18 times 17 divided by 4 by 3 by 2 by 1. Okay. And so let's figure out what that will be. So 20 times 19 times 18 times 17 is going to be 340. 4 times 3 times 2 times 1, 24. So 340 divided by 24 is going to be 14.16 repeating. Let's double check on that. 20, 19, 20, 19, 18, 17. Yeah, no, we definitely didn't get that right. Okay, so that is going to be, let's rewrite this, 116,280 divided by 24. That's going to be 4,845 combinations. There we go. Perfect. So a lot of combinations that we can pick. Okay, so that's question 105. Let's take a look at question 106. Okay, so question 106, hold on, there we go. Question 106 is a researcher wants to test a new padding for a pillow. They give 100 people the old padded pillows and 100 people the new padded pillows and record the numbers of continuous hours of sleep each person sleeps. What data gathering technique is used? Okay, so this is just comparing the methods that we've covered. We have a couple different ways. Let's say we have a population of n, and let's say n is a huge number, and I don't have time to sample them all, so I pick a few, and I say, well, out of these 4 people, 2 of them did A, and so that 1 out of 2 can be correlated to half of all sampled size, which means half of these million people are going to be roughly. That's not what we're doing, so we're not sampling. Not a sample survey. We could look at the other one where we go through and we look at, let's say we have another million people, and I walk around and I say, hey, in this path I notice A, B, B, A, B, and I just wander around. I say, okay, out of my observed, I have 1, 2, 3, 4, 5, 6 out of 7, 8, 9 people, so 2/3 did my observed behavior. This is what we call an observational study. not what we're doing either. What we're doing is we're artificially introducing A goes to 100 and B goes to 100, and we're recording some other metric out of that. So A produces X out of 100 and B produces Y out of 100, and we compare these two. This is what we're doing. This is what we call an experiment. Okay. It's 106. Let's take a look at 107. Okay. So suppose we have a student that has a test scores with a normal distribution with a mean of 81 and a standard deviation of 6. What is the z-score of a student earning 86? So with a normal distribution, what we know is that out of all possible scores, most of the scores are centered around some number. And that number that is the mean of 81 means the students were centered around a score of 81. If we had a standard deviation of 6, that means that of the scores with plus 6, so from 87 minus 6, 75, that 68% of all students scored between these two scores, meaning they were very uniform. Their knowledge was roughly equal. So something was being taught, or they're all roughly on the same ground. If 68% of the students score within this, what happens if a student scored an 86? Okay. Well, to calculate z-scores, if you can read my handwriting, is going to be whatever our data value is, so our test minus our mean over our standard deviation. Okay. Okay. So if our data point, or our test, was an 86, our mean was an 81, and we had a standard deviation of 6, this is saying our standard, or our z-score for this particular student was 5 out of 6, or roughly, let's take a look, 5 out of 6 is roughly 0.83 repeating. That is their z-score, is a 0.83, meaning they're within a deviation, they're considered a normal student. And there we go.